So if the speed of light in a medium is less compared to the another medium, then that medium in which the speed of light is less is optically rarer medium. Okay, so speed of light in glass is 2 into 10 to the power 8 meter per second, and the speed of light in water is 2.25 10 to the power 8 meter per second. So here the speed of light in water is more, therefore water is therefore the glass is more optically denser. Okay, now let's see how does the light bend. Okay, I said there are two possibilities. One is the light can bend towards the normal or bend away from the normal. So take the first case. We have taken the two medium over here, air and glass. Glass is optically denser compared to air. Okay, so this is the surface separating this medium 1 and medium 2. SS prime is the surface. We draw the dotted line which is normal, and this is the incident ray AO. AO is the incident ray which is making an angle I with the normal. So I is the angle of incidence. So we saw that some of the light after striking the surface gets reflected, and this is the reflected ray. But we are not interested with the reflected ray, we are interested in the refracted ray. Some of the light, okay, they bend towards the normal over here. See, this is the original direction of the ray, and it's bending towards this side, which is towards normal. If it would have bent towards this side, then it would have been away from the normal. But here we can see that light, when it travels from rarer medium to the denser medium, is bending towards the normal. Okay, so from here we understood that whenever the light travels from the rarer medium to the denser medium, it bends towards the normal, and this is called the refracted ray. And this delta is the deviation, the angle of deviation. Okay, this deviation measures the how much it is deviated from the original direction. This dotted line is the original direction of the incident ray, and this is the refracted ray. So this is the change in the path. Okay, delta measures the change in the direction of the incident ray. Again, the another case. So here the first medium is glass, which is denser, air is the ray medium. We have just reversed the medium now. Incident ray is incident on the glass, and it is striking the surface separating these two medium. I is the angle of incidence, reflected ray, refracted ray. So it should move like this. This is the original direction of the incident ray, the dotted line, but it bends away from the normal. Okay, delta is the deviation away from the normal, and this R, angle made by the refracted ray with the normal, we call it R, which is angle of refraction. Okay, so here we saw that whenever the light travels from denser medium to the rarer medium, it bends away from the normal. Okay, so now we understood when does it bend away or when does it bend towards the normal. And the third case is also there. In the third case, what is happening, that incident ray is striking the surface normally, that is I is 0 degree. Okay, because normal, this is a plane surface, and the perpendicular to this plane surface is normal, and incident ray is lying in the same normal. We know that the angle of incidence is the angle between the incident ray and the normal, but both are lying in the same line, therefore angle of incidence is 0. Okay, so do not say angle of incidence 90 degrees. Some people get confused over there. You have to be very careful. What is angle of incidence? Angle of incidence doesn't mean angle between this incident ray and the surface. It means the angle between the incident ray and the normal. For example, here, angle of incidence is the angle between incident ray and the normal. Understood? Good. So whenever this angle of incidence is 0 in this case, then the refracted ray doesn't suffer any deviation. Refracted ray doesn't suffer any deviation. That means angle of refraction is also 0. So only if the light strikes the surface separating these two media normally, making the angle of incidence 0, then the refracted ray will pass undeviated. This is very important for you to understand. Now let's talk about what is the cause of refraction. Okay, see, the cause of refraction is very simple. The main reason that light changes its path is because whenever light travels from one medium to another medium, its speed changes, as you know. If passing from one medium to another medium, the speed, light speed slows down, like this example. Here the air air to glass, the speed of light, it bends towards the normal because in the glass what's happening? The speed of light slows down. So whenever the speed of light slows down, it bends towards the normal. Here in this case, this is glass, this is air. So whenever the speed of here, if the light travels from glass to air, here the speed of light increases. Whenever the speed of light increases, it bends away from the normal. Okay, so that is the reason. That's the cause of bending of light. Okay, so bending of light, the main reason of bending light is the speed of light changes as it moves from one medium to the another medium. If the speed of light remains the same in passing from one medium to another medium, then the ray of light doesn't bend. It passes undeviated. But there is one exception. But whenever the light is incident normally from one medium to another medium, the speed of light changes, but the direction doesn't change. So only if the light is incident normally, even though the speed of light changes, the direction doesn't change. There are two explanations over here. One explanation is the mathematical explanation, which I'm gonna teach you once I do the laws of refraction. The other explanation you can consider like this. Again, this explanation maybe it is difficult for you to understand because you have not if you have studied light as a wave, then what, see, if you studied light as a wave, or just consider light as a wave over here. So whenever the light is incident obliquely, whenever the light is incident obliquely, then all the paths of the light, all the waves, all the paths of the wave, okay, if you consider light as a wave and it is striking obliquely, then all the parts of the wave is not striking the surface at the same time. Okay, some of the parts of the wave is striking first and some of the parts of the wave is striking later. As a result, as it moves to the another medium, here also what happens that speed of light as a wave, okay, changes. The speed of light changes as it moves from one medium to another medium. But different parts of the wave are striking the surface at different time. Therefore, there is a bending. But whenever there is a light striking the surface normally, then all parts of the wave are striking the surface at the same time and they're being slowed down at the same time. Here then they're not being slowed down at the same time. Therefore there's a bending. Here they are being slowed down at the same time. So even though the speed of light changes, they travel undeviated. Okay, this is one part of explanation. There's one mathematical explanation too that I will teach you once I finish this laws of refraction. Just like the laws of reflection, we have a laws of refraction. What do you mean the laws of refraction? Laws of refraction simply tells what are the rules should be followed when the lights get refracted. Okay, the light follows some certain rule in the phenomena of refraction. First rule is that the incident ray, refracted ray, and the normal, they should lie in the same plane, which is similar to the first rule of reflection. The second rule is important of here. Second rule says that the sine of angle of incidence to the sine of angle of reflection, okay, the ratio of sine of angle of incidence to the sine of angle of reflection has to be constant, which is different from the laws of reflection. Laws of reflection said that angle of incidence has to be equal to the angle of reflection. This much is only needed in case of laws of reflection. But laws of refraction, for the case of laws of refraction, this is not true. This is not true. This is true in case of reflection, but this is not true in case of refraction. So second rule is different in the refraction. Second rule says the sine of angle of incidence, ratio of sine of angle of incidence to the sine of angle of reflection has to be constant. Okay, it has to be constant, and this constant is called mu12, which is the this means it's called mu12. This means refractive I'm sorry, refractive index of second to the first medium. This sine I and ratio of sine of I to the sine of R has to be constant. This has to be constant. The constant, let's say it is mu12. Mu12 is the refractive index of second medium to the first medium. This mu12 has a physical meaning. It is constant though, but it has a physical meaning that we'll study after this. Okay. So these are the two rules. The rule says this sine of angle of this incidence to the sine of angle of refraction has to be constant. So this rule has to be followed. Okay, this rule has to be followed. If this rule is not followed, then those if sine of angle of this sine of angle of incidence to the sine of angle of refraction is not constant, then this is not a refracted ray. Okay, this has to be followed. So these are two rules.